here it goes. So this is a section that's on domain and range. And domain and range is going to be hugely important to us as we travel through pre-calculus, because every function we study, we've got to talk about its domain and range. So it's a topic that's going to come up all year long, and we really need to get a handle on it. I'm not sure how much you talked about it in Algebra 2, but it's a hot topic in pre-calculus. So what I want to do, and I posted this too, so if you printed it out, great. If not, just loose leaf paper is fine. I want to talk about some things that he talked about on the video. The first thing is what's domain? And if you think about domain and what it is, it's all the possible x values. So all possible, oh, by the way, I'm going to take roll today by sometime during our lesson stopping and asking you a random question, and you have to put your answer in the chat, okay? Because here's our story. I get a lot of you with the black screens in your names, which is cool. Okay, that's not an issue. But I don't know where you are and what you're doing. You could dial in and then wander away. And so, for our attendance purposes, I'm going to just stop at some point and ask you just a random question. You're going to answer it in the chat, and that's how I'm going to go back and take roll, okay? I'm just giving you a heads up so that you don't run away, because this is really important. You're going to need me today. All right, so domain's all the possible x values for your function, and range, of course, is going to be all the possible y values. All right, that's not so hard to grasp. But if I go to the right here and I talk about open circles, let's talk open circles, because up until this point in math, you have probably done open circles, right? When you go to graph something, if it's not included on the graph, you use a big old fat open circle, which is fine. But really, what we're going to be doing in pre-calculus is interval notation. That's going to be our hot thing. This interval notation is going to be primarily what we will use for the rest of the year. And so if you have an open circle, in interval notation, it equates to parentheses, meaning it's not included. That point is not part of the graph. Same thing that the open circle means, my parentheses mean. And if I were an inequality, to write it as an inequality, if it's not included, then that would have to be either a less than sign or a greater than sign. It doesn't have the little equal to doodaddy with it. It's just less than or greater than. But if I'm a closed circle from back in the day, in interval notation, that means a bracket. And you have to be really specific, because honestly, when you're making a bracket versus a parenthesis, they kind of could look the same if you're a sloppy writer. So be careful, my sloppy writers. You got to be very specific on whether it's got the parenthesis or whether it's got the bracket. That means included. And for an inequality, it would be less than or equal to, or greater than or equal to. So open circles go with parentheses, closed circles go with brackets. And again, we're primarily going to be using interval notation. We're not going to be doing the inequality stuff much. So the last piece that I want to show you before we try a problem together is looking at, here's how we're going to write this with interval notation. The domain is going to be either a bracket or a parenthesis, and you're going to take the leftmost point and the rightmost point, whatever they might be. Remember, because x's on your x-axis go left and right, so it goes left to right, and then you're going to close it up with either a bracket or a parenthesis, whatever's fitting. Either it's included or not included. So domain's going to go left to right. If I look at the range, same idea, bracket or parenthesis, but it's going lowest, because now you're talking the y values, right? So the y values are read vertically. So you want the lowest value to the highest value. Close it up with a bracket or parenthesis, whatever's appropriate. Now, as I'm going along, feel free to unmute yourself and ask a question, or feel free to put it in the chat, whatever's comfortable for you. But stop me if you get stuck. Okay, so let's go to the picture I've got here. Now, you don't have the picture unless you printed this out, but we can kind of just look at this together. So If I, wonder if I can zoom in and it'll be happy. No. Okay. Anyway, if I'm looking at my picture and I go left, we always read left to right just like we read a book. So the first thing I come to if I'm coming along this graph is this point right here. Well, I'm looking left. I'm looking at x's. That's at -4. Now there's an open circle up here, but there's a closed circle that's down here. And so that makes me kind of question, am I going to have to use a bracket or a parenthesis? Is it included or isn't it included? And the question is, do you have a point there? Answer is yeah, you got a closed circle right there. Closed circle always wins, is kind of how it works. He dukes out the open circle and he wins. So the leftmost point, if I'm looking at my leftmost point is at -4, and it actually touches there, so I'm going to use a bracket next to -4. And then I come along the graph, -4, here's my x values, still going, still going. I get to 0 and it's got to jump. But it's got a closed circle here at 0 and an open circle here at 0. Closed circle wins. So it keeps going. It goes from 0 and it keeps going. This is kind of like an upside down parabola that keeps getting wider and wider and wider and wider as I go along. And so it actually keeps getting, because it keeps getting wider, it goes to infinity. And so any infinity that you come across is always going to be a parenthesis. You might want to make note of that somewhere. Let's go over here. If I have plus or minus infinity, it's always a parenthesis. Plus or minus. I didn't write that very well. Let me write that a little bit better. And here's the story of why that is. If I'm thinking about infinity, can you tell me specifically what infinity is? And all you know is that it gets bigger and bigger and bigger. But you can't tell me specifically what infinity is. And since you can't tell me specifically, then I can't include it because I don't know what it is. So that's why we always use parentheses with those values. All right, so that's my domain. Then I'm looking at the range. Range is lowest to highest. So how low does it go? Well, there's an arrow right here. And that arrow means it keeps getting lower and lower and lower, which means it's going to negative infinity. So the lowest it goes is to negative infinity. I don't know what infinity is, so that's a parenthesis all the time. And I travel along, and the highest, I'm looking for how high it goes. Well, it stops here at 0, but you still have part of the graph that continues on. So the highest it goes to is at 4. So this is 2, 4, and 6. Highest it goes to is 4, but it's got an open circle. So the open circle means that it is not included. I'm going to close that with a parenthesis. All right, we're going to talk more with some of the examples that were from the video in just a second. The inequality part of this, and when we get into the notes as well, I'm not too concerned about that. That's more of an Algebra 2 type concept. It's good to kind of refresh your memory, but like I said, this interval notation is going to be our predominant language when we're talking pre-calculus. So if I were to write this as an inequality, it would be my x values are greater than or equal to, remember the bracket there, -4. This means it starts at -4 and goes to infinity. This means the same thing. Starts at -4, goes to infinity. This one is all the numbers less than 4, but it's your range, so it's the y values. So as an inequality, it's going to be y is less than, not equal to, 4. All my y's are less than 4. All right, now that should put us at a place where we can now get into the pictures that we started with, actual notes from 2-2. Now he went through these, in my opinion, kind of fast in the video, so you slow me down if you need to slow me down. The first thing he talked about were these basic functions, and these are ones that we're going to study throughout the year. These are all the basic functions we're going to look at. So we'll start with the linear function first, and he is y equals mx plus b. That's the formula that you would see if it were a line. Remember, the x only has a power of 1 on it. But if I come to a quadratic, then he's an x squared. If I come to a cubic, he's an x cubed. Sometimes the cubic guys can get more bumpy. They can have more bigger bumps than what this one is. This one's just kind of a nice fluid one. That's x cubed. Rational functions, we're going to study those. They have asymptotes in them. We're going to talk asymptotes as the day goes on today. But their equation would be like 1 over x. The middle guy's the square root of x. This guy's an exponential function. That's like some constant. It can be any constant at all that you want raised to a power. Say it could be 2 to the x, it could be 3 to the x, it could be whatever you want. Some constant to a power. Logarithmic ones are when they're the log base b of x. The base could change. Sine graph is sine of x. Cosine is cos, cosine of x. Absolute value, single line. Absolute value, you've seen those before. This guy's a funky guy, greatest integer graph. He's special. He's like a bunch of steps. They're not connected, right? This guy has a double absolute value symbol, meaning the greatest integer. And the last one we don't see very often, but the last one is 1 over 1 plus e to the negative x. That's the logistic function. That one won't come up too often. Now, he gave you all these graphs when he did these. The very first practice problems are a set of like 9 of these or something, where you have to see if you can remember what they look like and draw the graphs. So that's going to be the beginning of the practice problems, is kind of relating back to this first page. All right, so let's look at some problems together. Now, these were the notes that he did with you. What I want to do is pick and choose a couple of these that we're going to look at in detail together so that I can kind of make some sense out of hopefully what he was trying to tell you. So, increasing, decreasing. If I read a graph from left to right, I'm going to do number 1, and I'm starting here and I start tracing the graph. I'm going up, right? So in this part of the graph, I'm increasing, which isn't a hard concept to understand, right? So I'm increasing until I get to this place right here. Well, the question is, where is that? So I'm going to give it a coordinate. I'm going to check it out. He's at -1, -2, -3. I'm going to say, let's see, if I were to use the same, would we say maybe that's at 2 if we were estimating? All right, so it's increasing until this point. Let's keep reading the graph, and then I'm going to go back and answer the question. Then my graph, if I'm tracing, starts going down. So for this part of the graph, now I'm decreasing until I get to this point. And I'm going to estimate about where that one is, and I'm going to say that that's at about 1, -2. And then I'm on the road again with my graph, and I'm going to trace it some more. And now I'm going up again. Kind of like a roller coaster, right? Going up again, I'm increasing until I get to this point. Well, where is that? 1, 2, 3, 4. 1, 2. This is about at 4, 2. And then I'm constant for the rest of the graph. There's an arrow at the end. All right, that is not rocket science yet, but here's where things get a little confusing for kids. When I'm looking at, and you want to write it in the margin over here or off to the side somewhere, you want to say that you're looking at the y's, at the y values, but you're writing the x values. And you say, what are you talking about? And here's what I'm talking about. So if I'm talking about kind of chunking up this graph, right? If I'm talking about chunking it up, I'm looking at this first section that's increasing, and I'm just going to kind of show you that space, right? We say it's increasing in that place. Well, I'm looking at this, when I'm looking at that section of the graph, I'm going to write the x values because it's increasing from where x is -infinity and it stops increasing at -3. So the very first thing I have over here is this first section of increasing goes from -infinity to -3 if I chunk off that part of the graph. -infinity, and it's not -infinity because the y's are going to -infinity, it's -infinity because the x's are going to -infinity. Kind of weird. To -3. Okay, so let's talk brackets or parentheses. Another discrepancy. So Let me come back and talk brackets or parentheses, and we'll leave that blank for a second. Let's go to the next section of the graph and talk about what it's doing. So now I'm looking at the section of the graph that goes here, decreasing, right? So where is it decreasing? Well, it's going down, but I'm writing the x values. So if I'm writing the x values, it's going from -3 to +1. Oop, did one parenthesis there. -3 to +1, that's the section that is now decreasing. All right, now let's talk brackets or parentheses, because I can make the point I wanted to make. Do you see how at -3, it's part of the increasing part and it's part of the decreasing part? So for me, can you be increasing and decreasing at the same time? I don't know. I don't think so, right? So for me, I tend to put these as always parentheses. I always use parentheses with increasing, decreasing, because in my mind, I can't be doing both at the same time. Now, mathematically speaking and textbook-wise, some textbooks use brackets and some textbooks use parentheses. So in other words, it does not matter. Whatever makes your happiness flow, you can use either parentheses or brackets for increasing and decreasing. But it's extremely important when you go and talk domain and range. Domain and range, it's very important whether you use a bracket or whether you use a parenthesis. So increasing, decreasing does not matter. Do whatever your heart desires. But for domain and range, you're going to be careful. You got to actually use the brackets and the parentheses the way they're supposed to be used. All right, so let's finish the question. The next section of the graph is this section here. It's increasing. What are the x values? They are 1 to 4. So increasing from 1 to 4. And then it's constant for the whole rest of the graph. So it's constant from 4 to infinity. Remember, infinity gets a parenthesis. All right, so there's increasing, decreasing. He did this other example for you on the video. Then you got into some domain and range of graphs. I want to talk before I try to do numbers. I want to do numbers 5 and 6 with you just real quick too. But I want to talk about asymptotes. And also, I wanted to mention that if you are negative infinity to positive infinity, it's the same thing as, this means all real numbers. It's a fancy pants R. Let me show you how it's made. If you do a down, 2 lines down, and then turn it into an R, that means all real numbers. So whenever you have a graph that goes, this one was for the range, it keeps getting wider as it goes, so it hits every y value. You can either say all real numbers, or you can say between negative infinity and positive infinity, whichever, these mean the same thing. All right, here goes asymptotes, off to the side again. This is a really cool word. Hey, I learned about asymptotes today. There are 3 types of asymptotes. The first one is a vertical asymptote. I call them VAs, V-A, VA. And that would be some kind of, normally we use dotted lines to show them, some kind of vertical line in the graph that looks like this. So I can see in number 6 that's here, number 6 has a vertical asymptote right here. So you may say to yourself, what the heck's an asymptote? And so here's the theory. Now you have to think about this theoretically, okay? If I am, right now I'm sitting at my desk and I can walk to my classroom door. I want to walk halfway to the door. All right, so I'm going to go, get up, I'm going to walk halfway to the door. And then I'm going to walk halfway to the door again. And then I'm going to walk halfway to the door again, and halfway to the door, and halfway to the door. Am I ever theoretically going to get to the door? Anybody? No, thank you, Noah. Okay, good. Right, so theoretically, I'm never going to make it to the door. That's the exact idea of an asymptote. It's a line that the graph approaches but doesn't touch. Or I should probably be better, it rarely touches. So it's a line that the graph approaches and rarely touches. You can have a vertical asymptote. You can have a horizontal asymptote. Horizontal. They go, of course, horizontally. That would be like what I've got going on in number 5. Right, horizontal asymptote. Or sometimes, and we're going to study this eventually, that you could have a slant asymptotes. Horizontals, by the way, are ha's. Slants are sa's. And if I'm a slant asymptote, I'm slanted on like a regular line. All right, so let's go to domain for number 5 because that's a little bit more tricky. So domain, remember, is left to right. How far left does it go? How far right does it go? So left, it keeps going forever. It goes down to negative infinity. And you know negative infinity is a parenthesis. How far right does it go? It stops right here. Well, that's an x value of 4. And it hits everything in between. So it's going to stop at 4. Does it touch it? Open circle? No. Range is lowest to highest. The lowest y value is right here at negative 2. Does it touch it? Well, the graph continues on. There's no issues there. So yes, bracket. How high does it go? Well, it goes as high as this asymptote is. Remember, it's not going to touch it. The thing I said about rarely, sometimes, very rarely, a graph can cross a horizontal asymptote, but it's never, ever, ever, ever going to cross a vertical asymptote. So sometimes it'll cross the horizontals. In this case, it doesn't. It kind of just comes up and skates along it. But just so you know, you're never, ever going to cross a vertical. You might sometimes cross a horizontal when you see things later as we go along the year. All right, so the lowest it hits is negative 2. The highest it hits is 3. It's an asymptote. You can't touch that, parenthesis. As far as the inequality goes, if you're ever trying to do a between statement like this, you want to write the number negative 2 on the left, the 3 on the right. Range are the y values, put that in the middle. And then put in your less than signs. These go with less than signs. And so the less than, this one's going to be less than or equal to because it's a bracket. This one's just a plain old less than. And that's how I would write the inequality that goes with that. So negative 2 on the left, 3 on the right, y in the middle, less than signs. This one's equal to bracket, this one's not, so parenthesis. And one more time about the rarely touch thing. Back over here with my asymptotes. You're never ever going to cross a vertical asymptote. You can have a graph that will occasionally cross over the horizontal asymptote. Doesn't happen often. I would say it's 95% of the time it won't. But there are occasions we're going to study later in the year, and I don't want you to come back to me and say, yo, winner, you said they're never going to cross, because that's not true. So I'm going to tell you that 95% of the time you are not going to cross a horizontal, but it can happen occasionally. All right, last one on this, and then we're going to get into some practice problems. Number 6, this guy has a vertical asymptote. Yes, I know I didn't fill in this inequality. I'm really more concerned about the interval notation than the inequality notation. So as you're doing the practice problems, I'm all right if you just do the interval notation and skip the inequality part, okay? All right, so number 6, domain, furthest point to the left. Well, I'm reading this across. There are no points, are no points, are no points. Oh, there's a point at negative 3. So at negative 3, I have a value. That's my furthest left value. So negative 3. Let me put it up a little bit. And then the furthest right value, oh, by the way, parenthesis or bracket, open circle, not included. All right, I'm going to skate along this thing. Now I'm going x values. It gets really close to negative 2, but I've got a vertical asymptote that it won't cross. So it's not going to touch that at negative 2. So the first section of the graph, left to right, is this guy here. It goes between negative 3 and negative 2 and won't touch either of those. And then I keep reading the graph. The graph starts again at 1. All right, 1. So I'm going to have a second value here. Here's a 1. Does it touch at 1? Nope. Open circle, parenthesis. And then I keep riding along this thing, x value-wise. I get to 4 and it stops. Well, it stops here, but then I've got values down here that start at 4 and keep going to 6. Is 4 included? Does it keep going? And it does, because there's a closed circle here and an open circle here. And so I keep going. So really this one goes from 1 to 6. What's happening at 6? Is it included or not? And it's a closed circle, so that's going to be a bracket. That's the domain for this one. There's a whole chunk of missing pieces here in the middle that you're not including. So you say that you can draw it from -3 to -2, and then you got to pick up your pencil and you can draw it again from 1 to 6, and it hits all those x values. If I go with the range for this one, the lowest it goes, now I'm looking this way at it. I'm looking at it this way, reading it this way, lowest to highest. The lowest it goes is to -infinity. So -infinity is my start. I don't know what it is, so that's a parenthesis. And then I have y values that continue all the way till I get to -2. All right, these are included. And just because this is an open circle, you've got a closed circle over here, so you're going to continue on. So the highest that this piece goes is to -2. So this one's chunky too. You've got two parts to it. So the next piece it goes to is to -2. It does not touch their open circle. And then I'm looking at the next piece. There are no y values, are no y values, are no... Oh, there's a y value at 3. Doesn't touch it. And it goes all the way up to a y value of 6 with a closed circle, and it does. And so there's your interval notation for that guy, for number 6. Now he kind of went through them fast. I hope at this point it's kind of making a little bit more sense, kind of solidifying what was shown on the video. I am going to stop and take questions. If you have questions for a minute. Anybody? Okay, so here's my attendance question. Oh, there's a question. Go on.
So in the video, he did something where there were like in that last problem, when it's two different like sets of like exercises, he put like a U in between them. Do you care if we do
Oh, yes.
does that, or do you either way?
Yes, great question. Okay, so here's what she's saying. He used a notation, and he put it like this. I'm going to rewrite it down below here. He put it as -3, -2, and then he did this U that was next to it, and then he did 1 to 6. This means union. It's a math symbol that means union. It really means the same thing as the word and. So it's -3 to -2 and 1 to 6. We can use that if you want to use that. Probably you won't see me using that much because really that's saying the same thing. It's these two sections. It's this section and this section. So you can use that mathematical symbol if you'd like, but it really means the same thing as what we've got going on. It's a really good question. He did do that. You're right. Yeah. Okay, so we're going to stop and do our attendance question. Here it is. The question is, what's your favorite kind of cookie? Put it in the chat. Okay? For attendance purposes, you got to tell me what kind of cookie you like. Oh, an oatmeal raisin, that's a different. Pumpkin. Aren't you loving, Bella, the pumpkin stuff's coming out now? Like, oh my gosh, all the coffee flavorings and oh, so yummy. Len, I like those oatmeal chocolate chip cookies too. Yummy. All right, we are moving on. We still have some coming in. Oh, two separate kinds, Len says. Okay, so chocolate chips or oatmeal without raisins. I gotcha. There's I don't know. I think it's Duncan Hines. They make like a mix in a bag that's oatmeal chocolate chips that are so good, so yummy. Pretty much any kind of cookie, right? I tend to like peanut butter if I were to have a peanut butter. But Avery, you said peanut butter blossom. I wonder what makes it a blossom cookie. Like, what's the difference between a regular peanut butter versus a peanut butter blossom? She'll have to let me know. All right, so here come the practice problems. These are the practice problems. They don't really advertise very big that they're practice problems, but it's the next page that you come to in what I sent you for the packet. So these are the practice problems, domain and range. These first 12 questions are actually, oh, Hershey Kiss on top. Cool. Oh, that's amazing. Have you ever made, like, you can make the mix for, like, the peanut, we're specifically talking about peanut butter cookies, where you make the mix and you put them in, like, the little mini muffin pans, and then you can put a Reese's in it? Oh, my goodness. Good stuff. Okay, now I'm going to be hungry for cookies, right? All right, so that's kind of like what Avery's saying with the Hershey Kiss on the top. Good stuff. So these first 12 questions, these are all graphs that are the same exact question as what the front page of your notes are. They're saying, okay, well, what's this a picture of? What type of graph? What does that look like when you're looking at the front page? Which ones are these? So they want you to try to not look back in your notes if possible. Not a big deal at this point if you end up having to look back in your notes. Okay, so those are exactly the front page, no different. You're just telling which function it is and what the equation looks like. So they're the first 12 questions. Then you get down here to 13 and 14. So number 14 is the one I chose that I want to look at with you. The question says, identify the domain where the function is increasing, decreasing, or constant. Use interval notation. Okay, we can do that. So I'm skating along this graph and I'm looking at what it's doing. The first thing it's doing is constant, right? It's not going up or down until I get to this point. Well, where's that point? Let's figure it out. -1, -2, -3, 1, 2, 3. I'm going to give it a coordinate. And so there it is. All right, then the next thing that the graph does, before I even answer these questions over here, the next thing it does is it goes down. So now I'm decreasing until I get to this coordinate. Well, where's that? -1, 1. -1, -1. Nope, +1, -1. By the way, I make mistakes, and you can stop me at any point in time. I am not the least bit offended if you find me making mistakes. So please. All right, this is 1, -1. Get that right, Winner. All right, then I'm increasing again till I get to this coordinate. Where is it? 1, 2, 3, 4. 1, 2. And then I'm constant again for the rest of the graph. All right, so we have dissected this graph and figured out where it's increasing, decreasing, or constant. Now I need to put it together in the interval notation. So I'm looking at chunks of the graph. First chunk is this guy here where it's constant, and it's constant from -infinity. This thing keeps going on. It's constant from -infinity, and it stops being constant at this coordinate. You're looking at the y's, but you're writing the x. It's till it's -3. Again, you can use parentheses or brackets, your choice for these. Then it goes, the next chunk of the graph is this chunk, and it's decreasing. Well, where's it decreasing? From what to what? So from -3, use the x's, to +1, it is decreasing. -3, +1. Then the next hunk of the graph is increasing. What are the x values? From what to what? From 1 to 4. And then it's constant the rest of the graph. So from 4, going in an arrow to +infinity, and there you go. All right. Again, stop me if you have questions, but that's where we're doing with increasing, decreasing. We are moving on to domains and ranges. Numbers 15 and 16 at the top of the page are still increasing, decreasing, and constant. So we're going to go to these. Identify the domain and range. Use both interval notation and inequality notation. We're not going to do the inequality kind, so you can take that away. We're just doing the interval notation. And so the first one I want to look at is number 20. And these are our last ones for the day, by the way. 20, 24, and 26 are our hope to get through. Domain, left to right. Let's go left. Furthest point on the left is right here. Well, that's at 0. X is 0. So my first thing, it starts at 0. Open circle or closed circle? Well, it's closed right there, so I'm going to use a bracket. I'm going left to right. I'm reading it this way. So the next place I come to is 1. It's got an open circle down here, but a closed circle up here. Who wins? Right? The closed circle is going to win. So now I've got the closed circle up here, and it keeps going. So I do have a value at 1. It's going to keep going to 2. Open circle, closed circle. Who wins? Closed circle. Goes to 3. Open circle, closed circle. Who wins? Closed circle. Keep going. Keep going, keep going, and it stops. Furthest point on the right is 5. Now the question is, does it touch at 5? And you say, open circle, no way, Jose. Close it up. Now the range is a little bit more tricky, right? Because the range, now I'm looking at it this way. I'm looking at the lowest to the highest. Well, the lowest it hits is 0. That's not such a big deal. Does it have a y value at 0? Yes, it does. Bracket that in. But then, as I look at this, are there any y values between 0 and 1? And you say, nope, there's nothing there. But there are values at 1, and there are values at 2. There's nothing between, though, these things. So maybe this might not be the best way to write this, that it actually includes 0. Maybe we want to do it this way. Thank God for erasable pens. Hope you're not doing yours in pen. Scribble. All right, so I would say y equals. And it's because it's only on these whole number values. I have a y at 0. I have y's at 1. I have y's at 2. I have y's at 3. And I have y's at 4. I don't have y's anywhere else. They're the only y values I've got. And that's because it doesn't have any values that go between this. It's not like a smooth graph like the one up above is, where it hits all the y values as you go along. This guy doesn't. It's like it's called a step function. It's like it doesn't have anything in there. It's like you're going up a set of stairs. So that's your number 20. 2 to go. 24 is next. 24, again, your domain. Domain goes left to right. So let's read this thing. Furthest point on the left is this guy right here. That's at x equals -5. So -5 is the furthest point on the left. And if I look at that, that is included. It's got a closed circle, so I'm going to bracket that. And then I travel along, left, 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 left to the first point on the right. Well, there's a gap here, so I'm going to have to do this in 2 parts, because see how the graph has 2 parts. So when it's a 2-parted graph, a lot of times you're going to want to put it, unless there's some way that they're connected or whatever, there's something in between there, you're going to do them as 2 separate domains. So left to right, this furthest point on the right is at -1, and it doesn't touch there because it's an open circle. And so that's what that first part's going to be, but you're not done yet, the domain, because there's still more to the graph. So we've got to say what the rest of that is. So next piece starts at 1, x is 1, touches it, closed circle, and goes to the furthest point on the right, which is 5, but doesn't touch it, so you're going to parenthesis out that back side there. Same thing happens with the range. You're going lowest to highest, but you have to do it in 2 different sections because you've got 2 different parts. So you're going to go lowest to highest for this guy, lowest to highest for this guy. Now I'm going to stop for a minute. I want you to try it. All right, we'll see if we have matching answers. So I want to know, what's the range for number 24? Lowest to highest, it's going to have 2 pieces. Take a second. All right, let's see how you did. This one, the lowest it hits is -4. It touches it. The highest it hits is -2. Because there's a closed circle there, it touches it. So the first section goes -4 to -2. Second section picks up at 2, closed circle, include it, and goes up to a high point of 4, and it touches there at 4, so you've got a bracket with that one as well. So -4, -2 with brackets, 2, 4 with brackets. All right, here comes the last one. Woohoo! This one, you see how the graph has two asymptotes again. You've got an asymptote that's vertical. You've got an asymptote that's horizontal. And you've got two parts to the actual graph. So you're going to have two parts probably to your domain and range. So let's start lefting. If I go left, how far left does it go? It goes all the way down to, because of the arrow, to -infinity. So the first part of the graph goes -infinity, -infinity, trace it. Furthest point on the right is the x value here, which is at 1. That's for this section. This is an asymptote. It gets really, really, really close to that line, but doesn't actually touch it. Remember, vertical asymptotes won't touch? Parenthesis that. But wait, there's more beyond that vertical asymptote. So you're going to skip over the asymptote. Now you're going to start with this piece. This piece, thinking x values, it gets really close to the value of 1, but doesn't touch it. So parenthesis with a 1. And if I come along looking at x's, how far right does it go? It keeps going forever and ever and ever. And so this one goes to +infinity. Infinities get parentheses. Same type of thing for your range. Range is lowest to highest. So if I look at how low this goes, this guy has an arrow. So he's going down to -infinity. So the lowest he goes is to -infinity. I'm looking at this. The highest he goes to is where this horizontal asymptote is. Well, the horizontal asymptote's at -1. Does it touch -1? And it doesn't, because it's an asymptote. It's going to get really close to it but not touch it. So -1, don't touch that. Then I'm skipping over the horizontal asymptote. Remember, I'm looking at it this way. So if I skip over the horizontal asymptote, now I'm here. The lowest it goes, it comes skating along that asymptote again. And the asymptote's at -1. So it's going to be -1. And how high does it go? It goes up to infinity. Infinities get parenthesis. All right, so let me ask this question before I let you go. Do you want me to do any other examples up to 26? Do you feel like you have it, or do you want me to do another one? We've got a little bit of time. All right, I'll take it that you have it. Okay, so here's your task. Let me show you. So here's some due dates coming at you. Wednesday, that's tomorrow. By the end of the day tomorrow, Wednesday, you're going to take a picture of the practice problems 1 to 26. Now, they're the ones we just were doing, right? You're going to fill in the rest of them that we didn't do. So from 1 to 26, you're going to shoot me a picture or attach it to our Google Classroom page. Either way, that's due for Wednesday, by the end of the day tomorrow. Then I posted this on our Classroom page. There's a domain and range matching worksheet where I give you the domains and ranges, and I give you pictures, and you have to decide which one's which. So it's matching numbers with letters. That's going to be due for Thursday. You don't have to print that out. If you can do it on regular paper, that's okay too. So you'll see the matching activity. It's on our Classroom page. There is a question, 1 to 26, or the ones. All right, so back to this assignment, this practice 1 to 26. There's a question about that. That is starting with these guys. See how it says practice over here? These are the practice, the ones we just were doing the examples from. So practice 1 through 26. We did number 14 already. So you don't have to do 14. You're going to do up to 13, and then you're going to skip to the next page. You don't have to do 20, 24, or 26 because we did those already too. You're filling in the ones that we did not do, and then taking a picture and either posting it on our Classroom page or emailing it to me, whichever way is best. Same with this domain and range worksheet. You can do it on regular paper if you'd like. You can print out the one that I have there. Either way is fine, but that one's due Thursday, so that's your Thursday assignment. Also, you need to watch the 2-3 video before our class on Friday because I'm going to do notes on that. So I kind of run through the notes a little fast because I know that you've seen the video already. And then the other thing on your radar is that we are planning for a quiz on Tuesday on 2-1 to 2-3. That's the plan for the moment. It could be that we'll schnicks this to Friday. We'll see. Let's see how things go, how quickly you grasp section 2.2 and 2.3. But for now, I'm going to say it's Tuesday, and that's the goal. But if we have to, if you're really thoroughly confused as a class and we need more time, we can take more time. All right? So it is flexible, but for now, I'm going to say it's Tuesday. So, questions for me?